Login acceptance.
Welcome to Security in Software Development Process presentation. My name is Radek Grebski. I'm CTO of Stepwise. I have like 14 years plus of experience, mostly around JVM and stuff like cloud, Kubernetes, recently DevOps stuff and security. I'm also an optimization freak, of course, without premature optimization. And from time to time, you can see me at different conferences. Recently online, nowadays, I hope more times offline. Okay, what will be this talk about? I will briefly introduce why I have chosen this topic. I will briefly go through each stages of software development lifecycle, explaining how to make it secure. And I will, along the way, I will show you examples of using the tools you can see here that I believe can help you making your code, your application, and your software more secure. Okay, so why this topic? Like I said, I've been developer for 14 years, and what I noticed is that we as developers, we focus mostly on bringing business value. We solve business, yeah? Okay, I thought it's already the question to the slide. Okay, so I noticed that we mostly focus on a business value bringing to the software, and we don't have either time or there are always different constraints that blocks us to focus on the software. So, on the other hand, there are different guys, groups, or botnets that want to take advantage of our software. And I believe, especially in recent years, because of huge increase of attacks and breaches, we should put more focus to security. Okay, so let's start with software development lifecycle. It's simplified. Like we start with requirement analysis. We go through design, implementation, verification, or testing. And we do the release. And it's a continuous process in an agile way nowadays. We do it often, very often, and some companies do it like 1,000 times daily. So how to make it secure? I believe it's all about adding security aspects to each stage of software development lifecycle. So let's start with requirement analysis. So this is the very early stage of our project or our sprint, whatever. And at this stage, we should consider doing a security training to our team, to our company. Maybe there is someone in company who has already a security advisor role. Maybe we can take someone from external companies. At this stage, we should also not only get business requirements of our application, but we should also gather security requirements of our application, because having that at this stage will help us in another stages of software development. And we should also consider privacy requirements, because in a different way we want to secure data like IP address, even though according to GDPR it's a personal data and we should protect it. But we won't protect that data as much as we would protect, for example, ID number, first name, last name, and addresses. And at this stage, we should also analyze potential source of bugs in our project reality, which can be deadlines, which can be business logic leaking information, or simply not enough experience or not enough level is not that high of security aspects of our team, of our project team. So after requirement analysis phase, we have design phase. And at this phase, I guess after security trainings and getting more knowledge about security, we are already familiar with Open Web Application Security Project, which I will tell you a bit more in the next slides. We should already know what is Web Application Firewall. Also, I will show it on the next slides. And at that stage, we should consider either we need that in our application or not. We should, when designing, we should keep things simple, right? Because the more complexity we add to our system, the more complex it gets, it's hard to maintain, and there is a bigger possibility of security leaks in our application. And we also should secure database or other external system credentials. For that, for example, if we use Kubernetes, we can use kubectl. If we use any other tools, I'm pretty sure we can use Sops, which I will show you later on during the presentation, what advantages, what value can it bring to your project. We should also think how we're going to manage secrets, who will have access to which environment, to different secrets, and how we're going to store them. And at this stage, we should also think how we're going to protect data at rest and data in motion, right? In motion is the data we send over the wire, for example, and data at rest is the data we store somewhere. I don't know, database, buckets, whatever. At the design stage, we should also model threats basing on our designs. We should think what can go wrong. We should classify the data. We should analyze data flows in our application. We should document that threats, and we should define actions basing on those documented threats. And of course, we should test them later on. Previously, I mentioned about OWASP. OWASP has like a cheat sheet that everyone should be familiar with. They have top 10 security risks and top 10 proactive controls. Of course, at the top of those risks are different types of injections, stuff like broken authentication, insecure deserialization or serialization, cross-site scripting, and stuff like that. And one important thing, also using components and not keeping them up to date is a big risk. And as an answer to that, OWASP created also top 10 proactive controls, which is an answer to those risks you saw on a previous slide. So stuff like defining security requirements, validating input, handling all errors and exceptions, stuff like that. But this is a basic stuff. The more interesting document is OWASP Application Security Verification Standard. If you plan to do something like that, some standard in your project, in your company, this is a very good document you can start with, because it has lots of checkpoints, lots of pages. I just mentioned a couple of dozens or hundreds of checkpoints this document contains. Stuff like if you do planning, you create stories also for security aspects of that story. When you use logging, use common patterns, because monitoring and alerting at a later stage of project is going to be easier. Stuff like categorization of sensitive data, how to manage passwords. Do we want to hash them? Do we want to decrypt them? And do we want to check it against breached and leaked credentials? Is also a good idea. And stuff like input validation and credentials for intra-service communication should be based on rotating keys or passwords. We shouldn't, write credentials in stone and never change it, because no one will see the stone ever. Another interesting organization, if it comes to security, is CIS, which stands for Center for Internet Security. They have two things that may be in our interest. One is CIS controls, but this is more. This document is more about protecting our organization, our infrastructure, and stuff like that. For our development process, for example, more interesting is CIS Benchmarks, which is a set of documents that each document is designed for example, for operating system, for different servers, web servers, database servers, and stuff like that, and clouds and others, and also contains hardened images. Those are mostly virtual machine images for different clouds, but also they have hardened Docker images for AWS. So, for example, one interesting benchmark is for Kubernetes, where we have a checkpoint for control plane, nodes, kubelet, policies in Kubernetes, or pods itself. And there is one company, I think the biggest company if it comes to cloud native stuff and security aspects, which is Aqua Security. They created a kube-bench tool, which simply takes all the CIS benchmarks and runs them against our Kubernetes cluster. So let me make screen bigger. Okay, so let me look at my cheat sheet. Okay, so here I have checked out kube-bench project from GitLab, and it has different set of jobs for different cloud providers, right? We have a cloud provider for Azure, for Azure, for AWS, for Google Cloud, for IBM Cloud, and also there are jobs for on-premise installations. Here I'm connected to, I have set up Kubernetes cluster on Google Cloud. So let me once again take a look at my cheat sheet. So to run CIS benchmarks against my Kubernetes cluster, I can simply start a job. This command simply starts a pod on my Kubernetes cluster. And next, what I can do is simply see the output, which is going to be my report of security state of my Kubernetes cluster. Okay, this is not found, which is okay, because this cheat line is not complete. And as you can see, as an output, I get a report. Each point is from CIS benchmark documentation. I hope you can see it well. If not, I can make it a bit bigger. And you can see at point 4, there are workers being checked. And for each point that is failing, I have information. What should I do to align with that checkpoint? And what's being checked is worker node, as I said, Kubernetes policies, role-based access and control, service accounts, and stuff like that. And this, you saw it how quickly I was able to run and check my my cluster. This is easy way of checking our deployment environment. Of course, it's not being done at design stage, but later on. But I just wanted to show it to you next to CIS benchmarks. Another thing I told before is Web Application Firewall. It's a first line of defense. It protects you from many of those top 10 security issues according to OWASP. As you can see, OWASP also has its own mod security core rule set, which was originally designed for Apache servers, but later on they created abstraction out of it, and now mod security rule set has implementation that can be used as a plugins in Apache or Nginx servers. There is also NAXI project, which stands for anti-cross-scripting and SQL injection protection, and all major cloud providers have their own web application frameworks that you can utilize. And of course, Kubernetes ingresses also have WAF plugins. Okay, so at the design stage, we also want to secure our database. We don't want, unless ultra necessary, we don't want our database to face the internet directly. We want to encrypt connections to our database, just in case someone sniffs our traffic. We should use strong and unique passwords. We should rotate them over the time regularly. We should granulate permissions for applications, for users. If it's possible, we want to give access to only one table, one row, or a column if it's possible. If not, we can always use a view, limit the data we expose, and give an access to a view. And we should also back up our database or other external systems, and we should have a document saying, or a knowledge, which should be as a document, saying how to restore the backup. And we should try that procedure very often, just to be sure that in case of a crash or some situation, we are still able to restore the data from the backup. All major databases have a section in their documentation saying how to make the database more secure. For example, Postgres, Mongo, and Redis, and as well, there are CIS benchmarks for many databases available. At the design stage, we should also consider the surface, the attack surface of our application, all the in and out paths from our system, which can be UI, which can be headers we expose. For example, if you expose server header in your response, you let attacker know what type of software you're using on the first line. And of course, stuff like APIs, files, databases are also in and out paths and are also part of attack surface. And when we do that analysis, we should, with every sprint, every change in our system, we should update that surface, because it changed. Our software is being changed over time, and is developed. We also want to design deployment environments, right? For example, for dev, staging, and prod, different set of people, different set of applications will have access to and should have access to. We should manage those accesses, and we should plan how we're gonna store our credentials. For example, if we are using Kubernetes, are we gonna use secrets? Are we gonna utilize Sops? Are we gonna use kubectl or detect secrets tool that I will show on the next slide, how it can prevent developers to commit secrets into a code base. And we should design Git repositories. What we do at Stepwise very often is, like, we have, for a single application, we have 3 repositories. One is for a code base, for application itself, where simply developers have access to. Then we have, let's call it deployment repository, where we have a Helm chart for our application. For those who don't know, Helm is a way of describing application and packaging it, I mean infrastructure, and deploying it to Kubernetes. So to that project, DevOps guys gonna have access to. And then we have config project, which is simply use the Helm chart we created and deployed somewhere from deployment repository. Take an image of our application and deploy it. So we will have their secrets to production environment, to staging environment. So different set of people will have access to this config config repository because we want to keep it as secure and as less users as possible. And of course, if we use clouds, yeah.
Question. Doesn't it work against the DevOps movement? Basically, you're saying that developers will not have access to the deployment.
Yes, well, yes and no. In Stepwise, all the developers are also DevOps, but I guess there are some, well, they know Helm and they know Kubernetes, not that well.
Just to that repository, right? The deployment and config.
Yes, yes.
What's the point of having them if the same people have exactly the same access?
Because I don't believe every company looks like ours, and I believe there are still companies that have DevOps that do only DevOps stuff. I mean, they are not DevOps then. But just to make it clear and simplify, I use that split. Okay, and in config, as I said, we have credentials to different environments, and only the set of people that should know the credentials and stuff have access to that. Okay, now we move to implementation phase. At this stage, we want to keep libraries and dependencies up to date because, as I told on the previous slides, with every third-party library, we can import bugs and leaks to our application. Also, we should test authentication and authorization. In CI, have an automated test for that. And we should scan dependencies of our application. We should scan Docker images we produce. And we should log a lot to make monitoring and alerting easier after deployment. Okay, securing code. We should utilize static code analysis, and we as a developers should do it also in IDE. It should be done in a build phase. We should check it as well on CI. We should also do code review, not only checking business logic, but also security aspects of our system. We should handle all the errors and exceptions in our application, not to be thrown and left alone. And we should also take care of external systems credentials to be secured. Either we can use detect secrets tool from Yelp, or we can use Sops from Mozilla, or the best we can use both, because the purpose of one and another is a bit different. I will show an example on the next slides. And we should rotate those credentials. Okay, so let's take a look at detect secrets. This is my cheat sheet as well. So at the first, I run detect secret scan, which creates a baseline file with a current state of passwords in my application, in my Git repository. Then, having that plugged in CI/CD and updated, I can monitor it, right? So if I take a look at JSON representation of output, you can see that secrets detect works on plugins and filters, right? There are different plugins like Artifactory Detector, AWS Key Detector, Azure Storage Key Detector, and stuff like that. And it can detect a lot of credentials in our code base. And you can see the result path, section, when you can see that in config YAML file, there is a secret being stored. So if I run the audit against this generated baseline file, I can see that my config YAML, which is not that complicated, has a password stored in a secrets path, and I can decide what I should do with it. Do I want to have it in my repository or not? And after that, if I run the audit again, okay, this particular password was handled. I know what I want to do with it. So this tool, if we plug it into pre-commit phase on a Git client side, can protect us, but we can do the same on a pre-receive phase on a server side, just to reject the passwords that are in a code base. The second tool I prefer is a Sops, which stands for Secure Operations. It's a tool from Mozilla. It allows us to keep secrets as a code in a secure way. It allows us to encrypt values of YAML, JSON, and any binary files, and supports external key management system like GCP, KMS, AWS, and Azure, and also supports key rotation. So let me show you an example of Sops. Okay, I have already. So I have config YAML file, which is also pretty simple YAML file, and I have section for secrets, and I want to have them secure. And I also have a section that contains plain text values that that I want to stay plain text, because those might be properties that developers may want to change and should change over the time. So in that format, I wouldn't recommend to store passwords like that. But for one sec. But we can do it in a better way using Sops. Those commands I use to create symmetric encryption key on a Google Cloud. I won't run them now because they are already there. I prepared a key before the presentation. And if I wanted to use that key on Google Cloud and encrypt my YAML file, I simply call Sops, please encrypt the file, encrypt only path starting with secrets, use key from Google Cloud key management system. I add reference to a key, and I simply run it against my config YAML file, and as an output, I should get such a file. So let's run it. And if I take a look at my encrypted file, you can see that secrets are already encrypted. So whole that section is encrypted, and this is a secure way to store credentials into the code base. Your project may even be public, and it's secure. And those values I didn't want to encrypt are unencrypted. And you can see there is a Sops section in my YAML file. This is a metadata that is being used by Sops. It contains location of my key. It contains regex that I used for encryption. So now if I wanted to unencrypt the file, I simply call that command. I don't need anything, just tell Sops to decrypt the file, because all the metadata is in Sops section in YAML itself. And if I run it, you can see as an output, I can see unencrypted config file. which this unencryption can be done in a runtime in a secure way. And this way we have, as long as no one has access to our encryption key, we are more than secure to have, yeah.
Where and how you store the encryption key?
Where? It's in Google Cloud, for example, because there are key management systems. For example, Google Cloud has it, Amazon has it, Azure has it. So let me just show you one thing.
Here is locally, right?
No. Let me just list that for you. I'm using gcloud CLI here, KMS, which is key management system. Location is global, and if I run it, you can see that there is a key stored under that path. Project is Radek Sandbox on a Google Cloud. Key ring is Sops, called Sops because I named it like that, and key itself is simply Sops key, and its purpose is encrypt decrypt. So it's in external place. It's up to you where you're gonna store it, but there is lots of options to choose from. Even you can use PGP for that. Okay, I mentioned also about scanning dependencies, scanning images. We use Trivy, which is also a tool created by Aqua Security. There are some other options on the market as well, but we use Trivy because it can scan OS, operating system dependencies, and it can also scan programming language dependencies. Not all programming languages and package managers are supported, but all the languages have also their own tools to scanning dependencies for vulnerabilities. So, we can use Trivy, for example. We can use Trivy to scan Docker image from Docker Hub. For example, I'm using some random image. I just run Trivy I, which stands for image. I'm interested in criticals and highs, and in a couple seconds I should get the report from Trivy about this particular image. Okay, it's not very readable. I hope you can see it at least. And this scan, as you can see, Trivy updated database of vulnerabilities. It detected that this image is based on Alpine distro. And as you can see, it found 18 issues. Out of them, 17 are high and 1 is critical. And of course, you can, at each vulnerability, you have a link to the vulnerability. You can read a bit more about it and see what actions can you take, or to know if it was solved or not in the next releases. You can do the same. You can scan repositories. This is like an example Node.js repository. I can run a scan against it. Here as well, I'm gonna see multiple vulnerabilities, but most of them, I was scanning here dependencies from package log.json, which contains all the dependencies of that project. And what else I wanted to show you is I guess you know Alpine images. Those are lightweight without unnecessary dependencies Docker images. And as an example, I have taken. I want to do. Oh, not that one. I wanted to do a scan of regular full Nginx image. It's pretty old Nginx. It's 119. But that's not the point. If you take a look about how many vulnerabilities such an image has, it's like 16.3 for a normal Nginx image. And if I do the same for Alpine, you can see that instead of 60 issues, we have 30, right? So if you have an option to use Alpine images, I suggest so. Alternatives for Trivy scanner. There is Claire, there is Anchor, there is Quay Docker Hub has its own Dependabot. Google Cloud Registry has built-in vulnerability scanner. So there is a lots of options. We picked Trivy because it was the easiest one to use and user-friendly for us, but I encourage you to try others as well. Okay, so after implementation, we have verification and testing phase. Of course, here we should also take a closer look at the critical areas of our application. We should consider doing fuzz testing, which is testing our application with random data and seeing how it behaves under such input. We should utilize DevSecOps, which is having security awareness and using as much tools as it makes sense in your project to make our app more secure. I briefly told you about Alpine images, which are very secure, but there are also Distroless images. Distroless images were created by Google. They are simply Docker images without distribution. So there is also as less as possible dependencies, and you don't have package manager there, you don't have shell, so even so there is no way to go into that specific container using shell or something. And at that stage, we should also consider pen tests. It would be good if they were done by external company or external team that was not involved in development itself, to treat it as a black box and then try to take advantage over it. Okay, so at the last stage we have release, which should be done by, of course, CI/CD. We don't want to move artifacts manually and deploy them somewhere. We should think of monitoring and alerting for our application. We should think what events trigger our alerts or notify us that something wrong is happened. For example, status codes for one, we can monitor them, or we can monitor some other patterns or regex that let us know that something's wrong with our application. And we should also monitor traffic, because if our application is about to be run in Poland and used by I don't know, Polish only in Poland, if we see IPs from other countries or continents, we should take a closer look at that. Yeah, as I told before, we should use CVE scanners, and it should be from the very beginning. Not only in CI/CD, we should use them also in our container registries. Most container registries have it built in. For example, if you use open source one, for example, Harbor, it can integrate with either Claire or Trivy, and you can schedule scans on your container registry, and Harbor, for example, is gonna scan your images periodically, and will let you know if new vulnerability came out and one of your images started to be unsecure. And of course, we should do static code analysis, having security aspects in mind, and we should have automated tests for security. Another thing also from Aqua Security is a Starboard. It's a tool for monitoring deployment. So on a previous slide, I told you about Harbor and how to scan images on your container registry. But you know, the images from container registry may have, or most likely have already been deployed somewhere. For example, if we deploy to Kubernetes, we can use Starboard either as a CLI or as a Kubernetes operator. So as a CLI, we can plug it into CI/CD or run it on a scheduled basis, or we can install it as an operator on a Kubernetes. So every new deployment that comes to Kubernetes will be automatically scanned, and report is going to be generated. Of course, not only vulnerability scans are possible. There is a project called Polaris, which lets you audit your deployments to Kubernetes. For example, you may require all the deployments to have defined resources and limits for resources that are being used by given deployment, and you may require that. Otherwise, you won't be able to deploy to that cluster or to that namespace. Depends on configuration. It also allows you to run CIS benchmarks and create reports. It has plugins to Lens, which is IDE for Kubernetes, and Octant, and also can create reports in Prometheus and Grafana. Okay, so previously I created I created a deployment of Nginx on my Kubernetes cluster, and I can run Starboard scan. So simply, what I say, Starboard, please scan my deployment engine, which is called Nginx Devoxx, in a namespace Devoxx, and create vulnerability reports. And running that will create a scan. And after that, I'm going to stop it because I already have already run that. So I will create a report out of that. And if I take a look at that report, you can see that Nginx, the newer Nginx was used there. You can see a list of vulnerabilities. Here I can select any of these and take a look and see what's the vulnerability. Also there is, as I said before, it has a plugin to Lens. It's not gonna be nicer than that, I believe. And if I installed a plugin to Lens, and here you can see I have a section called Vulnerability Reports, and here my Nginx was already scanned, and I can take a look at a report of vulnerabilities, and it's going to be exactly the same as the one you've seen in HTML report. Okay, so to sum up the presentation, I encourage to think very early about security. Consider a training to your team, employ code review in a process, do the static code analysis, scan and update dependencies not only in CI/CD but on your container registry, and after deployment, scan the deployment. Secure the secrets. Don't commit plain text credentials. Take advantage of penetration testing. Use WAFs if it makes sense for you. Be familiar with OWASP and CIS documentation. And after release, monitor your application over the time. Are there any questions? Yeah.
Well, I believe it's expected to be very familiar with those different vulnerabilities which you discussed, right? Is there some simpler tool which, let's say, can be used in go-no-go scenario? Because, let's say, not all of those vulnerabilities are really maybe subject to the tackle.
Yeah, but I would be suspecting that there is something wrong with that image. So, yeah. You know, it's like with tests. If you have 100% coverage, it's something wrong with that. No, what I usually do, I do the scans, I do the reports, and I mostly look at criticals and highs. If you scan this image over the time, for example, one of vulnerabilities here was saying if you use a function called, I don't remember the name, let's say function X, be aware to escape the data before passing it to it. So you can, by reading the CVE documentation, you can protect yourself until the vulnerability is fixed. So if we are talking about go, no-go tool, it's, you know, I wish I had one, but most likely it's going to create a report for you, and it's up to you to go through it and react.
Another one, if you don't mind, what about penetration testing? What open source tool, like free to use,
I don't know a tool that would solve you the issue of penetration testing. I'm from a position of developer. I would rather hire external professionals that do the penetration testing, because in many projects I learned a lot from their reports, but I wouldn't do myself test, especially pen tests for software that I developed, because I would know how to write those tests that would pass simply.
then what about automation? Can you automate penetration testing, make it part of quality KPI?
I haven't done such thing, and I wouldn't recommend to do so. If we are talking about automation, it's more like integration tests of your security layer of your application. If we are talking about pen tests, you know, even if you automated your tests, you have deployment environment, which can be, you know, there can be Nginx in front of your application and a lots of different software. And only at that stage, when you deploy the application and the infrastructure is ready, you ask experts to do penetration testing. I wouldn't automate it anyway.
Can I have just one quick
Yeah?
question? Do you incorporate all those scans into your build pipeline, and do you block magic feature depending on the results?
I wish I had but as I said, those first slides, each project has its own constraints, and we are a software house, and each customer we work with has its own constraints and project reality. Somewhere they want a lot of features for yesterdays, and sometimes they don't really care about security. But we try to educate our clients, our teams, to do so. But if you ask me if we have all this stuff in any project, I would say no. But I wish I had. Okay, if there are no more questions, thank you very much for participation.